There are two different versions of Prim's algorithm. On the left, we have Prim's algorithm applied to a weighted adjacency matrix, and on the right, we have Prim's algorithm applied to a graph. We're going to see how the steps of one algorithm correspond to the steps of the other algorithm by solving these two algorithms simultaneously. Let's start on the left with Prim's algorithm applied to a weighted adjacency matrix. The first step is to choose any vertex and cross off the row corresponding to that vertex. So here I have a vertex D. I'm going to cross off the row corresponding to vertex D, and I place a number 1 above the column corresponding to vertex D. So on the right-hand side, that corresponds to choosing our starting vertex. So our starting vertex is D, so I'm going to start this algorithm by choosing my starting vertex of D. Now my start vertex has been selected. Let's go back to the left-hand side. The next step of Prim's algorithm says that of any of the numbered columns, in this case there's only one numbered column, choose the weight that is the smallest and is not currently crossed off. So of all of the weights in column D, the smallest weight is 9. 9 is not crossed off. So what I'm going to do is I'm going to put a circle around this weight of 9. I'm going to cross off the row corresponding to vertex F, and I place a number 2 above column F. So if we go to the graph on the right now, so we had our starting vertex was D, and then the next vertex should be F. So here I have vertex F, and the weight that was selected was the edge of weight 9. So I'm going to select this edge of weight 9. So now what this means, on the left where we are crossing out these vertices, so I crossed out the row corresponding to D, I crossed out the row corresponding to F, that is so that we can prevent forming cycles by backtracking to vertices that we have already visited. And furthermore, when we're doing Prim's algorithm, we have to make sure that the edges we choose are connected to our ever-growing tree that we're constructing. So initially, I just had vertex D selected, so there were 1, 2, 3, 4 edges connected to vertex D that I could have chosen from. I chose this edge of weight 9. So now I have 2 vertices selected, vertex D and vertex F. Now, of all of the edges connected to D and to F, I can choose the next weight. So now if I go to the left-hand side again, I'm going to look at column 1 and column 2. These are all of the edges that are connected to vertex D and to vertex F. Between these two columns, I'm going to choose the smallest weight that is not crossed off. And if I look down here at the bottom of column 2, there's an edge of weight 5 that is connected to vertex G. So I'm going to put a circle around the weight of 5. I'm going to cross off the row corresponding to vertex G, and I'm going to put a 3 above the column for vertex G. So on the right-hand side with our graph, we had this edge of weight 5 between vertex F to vertex G. So from vertex F to vertex G, I'm choosing this edge of weight 5, and we can see that this edge of weight 5 is connected to the ever-growing spanning tree that we are constructing. Okay, so now I have 3 vertices that have been connected by my, my growing tree. The next thing to do is, of all of the edges that are connected to our tree so far, we want to choose the smallest weight so that it doesn't form a cycle. On the left-hand side, I have 3 numbered columns. The smallest weight that appears in these 3 numbered columns, this looks like I've got 14 here, and I've got 14 here. So there are 2 different options that I can choose from. I can choose either this weight 14 between C and D, or this weight 14 between E and G. If I go to the graph on the right, I can see that there are 2 edges of weight 14 here between E and G, and here between C and D. So both of these edges are valid edges that I could choose next. So I'm just going to choose one at random. I'm going to go with this edge between C and D. And it looks like this one's giving me an error. Oh, so I missed this edge of weight 11. So 11 is actually the shortest weight. So I've put a blue circle around the weight of 11. I've crossed out the row corresponding to vertex E, and I put a number 4 above the column corresponding to vertex E. That means on the graph, I am going to choose the edge of weight 11 between vertex D and vertex E. And so I'm gradually increasing my spanning tree as I go through the steps of this algorithm. Let's continue this process. So the next smallest weight that is not crossed out in the matrix is this edge of weight 14 between C and D. And so I'm going to choose the edge of weight 14 between C and D. And now I have 5 different columns that I can choose from. Smallest weight is 6. So I circle 6. Smallest weight here is 6. I'm going to choose 6. And then finally, to the last step, there is only one row remaining. The smallest weight here is 12. And I'm going to choose the smallest weight here, which is 12. And in both cases, we can see that the weight of the minimum spanning tree is 57. And that is how the Prim's algorithm for a weighted adjacency matrix corresponds with the steps of Prim's algorithm for a graph. Thank you guys for watching.